So we're going to be taking this chisel cube, of course, as I described it, that we took a cube, a perfect cube, we sliced a part of it off, and that's gone. And now we have this form. So let's consider this as your top. So we need to illustrate this by methodology. So this is currently in a scale 1 to 100. Per centimeter is represented as 1 meter. So 1 centimeter, you could always take a regular type of ruler. Of course, we're going to be needing our F pencil, which is rounded off, a rounded tip. And we're going to need a .8 pen to illustrate. So we're going to consider this as the top. So we need to illustrate the top, front, right side, left side. And we're going to arrange it in such a way that this is going to be where the top, front, right side, and the left side. Of course, I'm going to be supplying the dimensions of this, all of this, in such a way that so that you have exact dimensions that you will replicate. Since this is derived from a cube, we need to start off first in illustrating squares or the framework for this. This is derived from a 3 meter by 3 meter by 3 meter. So first we need to try to position this in such a way that it is, so this is where the top is going to be. So first we need to determine what the center is. In order to do that, I'm going to be taking off the straight edge. So I already placed in the drawing limit. Cannot see it because it's very faint. I'm going to take that, those corners, and I am going to draw a line diagonally from these corners, exact corners. Just the area of the center, where the center is. Make sure you are in the correct corners. And now you can determine where the center is. I'm going to place back my straight edge. Of course, you can use the T-square if you are using a T-square. And I'm going to draw a horizontal line first. And this is going to be the vertical line going through transiting from the center. This now gives me context where to exactly place with the distance of where things are. I'm going to take these models. Okay, this is going to be where the top is. This is where the elevation is going to be. Okay, I'm just going to borrow some of that. And this is where the left side elevation is. Right side elevation is going to be. Everything is going to be connected. Okay, we're going to be making projections. We're going to be creating each elevation. And of course, the top is this. So there's no need for the rear elevation. So it's something like this, where we're going to be placing them. So we're going to take probably a distance for each of these elevations to be roughly about 3 meters away each. And this one to be another 3 meters above. But then we have to consider also where the lettering is going to be. We're going to be titling these things. So this is going to be the left side elevation. So currently I'm using 1 to 100, which is big. So make sure that you are using your 1 to 100 at all times, if you're going to be using that. Why scale? Why draw in scale? Because if this is the actual thing, a 3 meter would be, of course, twice the height of any person. And it's impractical for you to actually draw that 1 to 1. So that's 1 to 1 if it's the actual size. But for buildings, these are humongous edifices or objects. You need to scale them in order to fit a paper. So this is the one of the most simplest thing that you could do in terms of illustrating them. So we got the ideas of what we need to be doing. And also the lettering is going to be roughly about, the title size is going to be 5 millimeters. So that's enough space underneath. So when we title architectural drawings, we always usually label them underneath that drawing. So I've zoomed this a bit more closer so that you could see how do I do the initial frameworks of this. Okay, I'm going to be using my scalar ruler. So this is where the top is going to be, and this is where the front elevation is going to be. We already determined that this is going to be 3 meters away from each other. So I'm going to, from this center, I'm going to measure 1.5 meters, and of course another 1.5 meters below the center. This is a total of 3 meters. And of course the actual object is going to be 3 meters. So I'm marking these 3 meters apart. So this distance is going to be the void. So therefore, it's going to be the object, which is the left elevation, is going to be somewhere here, just exactly 3 meters, and another void where this is 3 meters of void. Here, we take that same thing. First, the void from the front elevation. It's going to be where it is. So I'm going to mark up 3 meters, another 3 meters is where the 6 meter is. And now I'm going to do first where the height of this. This is going to illustrate where the Z of the front elevation is. This is 3 meters. Of course, when we go on to the top view, this is going to be where the 3 meter mark is. So I'll start drawing these things. Just make sure that it's straight. So there was a mistake there. So if you have a mistake, I'd rather you gently erase that line with a kneaded eraser, like so. Again, light as possible. So the elevation is going to be spanning over here, here, vertical lines. Create first these things. So I'm going to draw these out, these guidelines. So this is where the area of maybe there's a mistake here. This is a bit off. So I'm going to erase gently. Has to be here. All right, so the top view is going to be something like this. So I'm going to start out with the penciling of this. So the measurement here, this edge is 0.5. So I'm measuring the surface, the top surface first. That's the point from the corner. And this is going to be 1 meter. So this edge now needs to be illustrated because I already determined where the corners are for these. Take my triangle. Now what about this one? This edge on the bottom. So it's going to be here. So it needs to be chamfered there somewhere. But first, of course, measure. So I mean that here, this distance is 2 meters. So I measured 2 meters here, place where the dot is supposed to be. And this is another 2 meters. 2 meters from the corner is here and here. Of course, that's 45 degrees. The 45-degree triangle. So this is at an odd angle. This is not 45 degrees. And of course, now you could create the front elevation of this. I'm going to be completing the top view first. I'll be using the point 1. Now the corners need to meet. They have to be exact. Or you can even go a little bit further, just as long as the corners meet and do not form any types of gaps. This is the 45-degree. Try to do it at one go. Okay, so this is not 45 degrees, so be careful with it. This is the top view illustration. If you take a look at our model, how it is when you view it. So this is a linear drawing. This is orthographic. Ortho means linear. It's very linear because now you're showing only the X and the Y axis. So this is the X axis and that is the Y axis. So the Z is not being deciphered here, or the distance. There's no information of that distance. Now, if you take this image alone, the viewer may not even understand what this is because he has no context on what the other elevations are. This drawing alone does not complete the picture. In order to complete the picture, you need to create the other associated drawings. Henceforth, it's called multi-drawing. So far, we've done the top view. Now for the elevation, the front, which is this somewhere. Before, of course, we do this, we need to now project some of the corners, which is this point. I'm going to lightly do a vertical line. Calibrate it with your T-square or your straight edge, where these are. That point and that. So this is already determined as the height. If I draw a person, that would be the scale, since this is derived from 3 meters by 3 meters by 3 meters. So now I can illustrate first the ground. I'm going to be using the 0.8 millimeter pen. I always illustrate the ground in architectural drawings, unlike, so we're going to consider this as an architectural building, and usually the ground is illustrated. I'm going to be using now my 0.1 again. Okay, now we take a look at the model. I need to illustrate this edge. So this edge, the slant of here cannot be seen because it's going to be linear against here. Here, the only line that is diagonal is going to be this edge. Now, in order to determine where that edge is, of course, it's from here, which is this, to here. So therefore, I'm going to draw a line here to there. Oops. Make sure there are no gaps in the corners, and of course vertically, and of course the other edge has to be aligned. So what about the other two? Now we're going to be using the projection type method of drafting. This is where that elevation is going to be created. So I'm going to use this edge here. I'm going to extend these lines a bit until they meet. I'm going to use my 45-degree as a way to project. Okay. Most likely, the buildings that or the designs you're going to be illustrating are not as simple as this. So therefore, there is a way to properly do things or project things when you're doing multiple drawings or orthographic of one object. So I'm going to extend this. It hits that 45 degrees. I'm going to extend down. Here we have that. Then we need to do the same. Again, there's this 3-meter gap. The 3-meter gap is somewhere there. We already made a point there. Create a vertical line, only meeting up to here. Use my 45-degree triangle. Make a 45-degree. Extend this line, which is aligned to the edge of your top view until it meets that corner. Now I need to project this down. So this is your projection line, 45-degree projection line. So the edges, this is an easier way methodology of illustrating the other two elevations, which is the right side elevation and the left side elevation. Here, there's this edge. I can project this now. When it hits that 45-degree projection line, you project this down. Now, I would like to see this in your exercises because it's a way for me to tell if your measurements and projections are aligned to each diagram. Now, if we take a look at the model again, we're going back. If you take a look at the right side elevation, you notice that, of course, there's a slant here. So if this is going to be here, here, and then that's there. The other point is going to be here. Instead of you just measuring that, you can project that edge going this way, first from the top. It's the 45 degrees. It intersects, put a point, and you project it down. And now you know the location without having to measure again. So I'm going to pencil that edge. Again, I'm going to ink it ahead so that you would understand what I'm trying to do here. Draw the ground line first. Don't confuse yourself when using this Uh, After get your point one, to draw that, draw the outer edges first. Make sure that the corners have no gaps. You can at least go over a bit in the corners. And then, of course, the diagonal. Make sure that you are in the correct alignment, and then you draw. The other elevation is the left elevation. It's pretty straightforward now. All you have to do is first do the outline, and of course, there's the ground line. Going back to your point one. Oops, make sure that don't leave a gap. Take your pencil, project it, because that's the these 2 points. It hits that 45 degrees, hits that 45-degree projection line. Project them. Why are we still doing that? Because if we take a look at our object and if we take a look at our left elevation, this is just a square. Well, the thing is with this, you need to also show what's behind. So a hidden line needs to be created in order to complete that picture, in order for them, for the viewers to actually have an understanding by looking at these multi drawings and in deciphering the three-dimensionality of this object. How is it? So it's like the opposite of this. It's a mirrored image. So therefore, it's somewhere like here. However, it's not going to be illustrated with a solid line. Instead, something that is in architecture, the hidden line is something that is symbolizes. So this is not correct. So the correct way angle is somewhere there. Make sure that, that's in the correct points. Hidden lines are mean that there's something that is beyond what is seen, or it's an edge beyond, or some an edge before the viewer. I'll show you what I mean when we are going to be creating roofs. So hidden line are these dash lines. The corners of these should be solidly meeting the line. There should not be a gap. Well, there you go. So we're almost complete. So if we take a look again and review this, that's the top, that's the front, that's the right side elevation, and of course that. Because, the hidden line edge is actually this. It's actually this, right? So that behind that's the hidden line because we want to show that edge. And one more thing that is missing here is the line values or the spatial cues, which is the use of stick line. So right now I'm going to be using zero point 0.6 millimeters. To note that hey, this edge, I mean this surface is actually much more forward than this surface here. I'm going to trace over carefully, thicken those lines, thicken that, thicken that. Make sure that you are aligned with your previous lines, thicken that. And of course, for the others, it's going to be this, and then press down. Make sure that they meet. They don't form any gaps. Here on the right side elevation, this is the surface is closer here, this edge. So make sure that you secure your triangle first or straight edge, and then there are no gaps again. And here we are, the complete sets of multiple drawings or orthographic drawing describing one object. By projecting the with a 45-degree line projection, Some of you might ask, why is there a gap between these? Why can't I just, draw one entire ground line? It's just to note that, these are different diagrams. So that's why there's a gap of the ground line. Now for the lettering. So taking in a centimeter or your 1 to 100, I'm going to space this is going to be about, I need a 5 millimeter height of lettering. So here, the minimum is going to be 2.5 millimeters, and I'm going to create that 5 millimeter height. Here, I'm going to put in the label scale or what scale this is going to be. So I'm going to be using a 3 millimeter height text, 1.5 millimeters gap, and then followed by a 3 millimeter. I'm going to do some extended guidelines. So this is where I'm going to pencil in, well, I'm going to be using my flat pencil to letter, right? Much closer. So it's going to be, of course, top. Be careful though. Made a mistake there. First, do the rest for the rest of your labels. Each drawing needs to have first the title of that, and then of course the scale. One, two, that's it. You complete the rest, of course, with all the details, of course. Of course, you do all the other titles here. Like this is going to be your front elevation, your right side elevation. You could just put in right elevation. Since there's no space, abbreviate. You can do like 11 and then with a period, right 11. This is going to be your left 11, and this is going to be your front 11. And of course, do not forget to put in the scale detail also. So scale 1 is to 100, scale 1 is to 100, it scales 1 to 1. So this is it. So therefore, I end this tutorial. So this is like a very straightforward type of tutorial. Of course, in future exercises, this is not going to be as simple as this, and we're going to be giving you challenging forms to illustrate. And thank you for following this video tutorial. Hoping that you learned a lot here. First demonstration of what an architectural illustration in orthographic is all about. Thank you.